In this question we are told, at time t seconds, where t is greater than 0, a particle p has velocity v meters per second, where v is equal to 3t squared I minus 6t to the power half j. Part A, find the speed of p at time t equal to 2 seconds. So the first thing we can do is find the value of v when t is equal to 2. We can substitute t as 2 in this given equation. So 2 squared is 4, 3 times 4 gives us 12i minus 6 root 2j. So that is our velocity of the particle, and in order to find the speed is just the modulus of v. So we square 12 and our minus 6 root 2 and find the square root. And if we put that into our calculator, that will give us 6 root 6 meters per second. Part B says, find an expression in terms of t, I and j for the acceleration of p at time t seconds where t is greater than 0. We've already been given an expression for v in terms of t, I and j, and in order to find our acceleration using the velocity expression, we just have to differentiate the expression of velocity. So in order to differentiate this, we multiply our coefficient by the power and reduce the power by 1. So this will become 6ti minus 3t to the power minus a half j meters per second squared. We're then told that at time t is equal to 4 seconds, the position vector of p is I minus 4j meters, and we have to look for the position vector of p at time t is equal to 1 second. So in order to find our displacement, we have to integrate the velocity with respect to time. So we are integrating 3t squared I minus 6t to the power a half j dt. So when we are integrating, we need to raise the power by 1 and divide by the new power. So this becomes 3t cubed over 3i minus 6t to the power 3 over 2 over 3 over 2j plus our constant c. We can simplify this to write it as t cubed I minus 4t to the power 3 over 2j plus c. In order to find c, we can use the information that's been given to us, where we know that when t is equal to 4, the position vector is I minus 4j. So when t is equal to 4, we know that s is equal to I minus 4j meters. And we can substitute this as I minus 4j is equal to 4 cubed I minus 4 times 4 to the power 3 over 2j plus c. So I minus 4j is equal to 4 cubed, which gives us 64i. 4 to the power 3 over 2 is 8, and 4 times 8 gives us minus 32 plus c. If we take away 64i on both sides, this gives us minus 63i. And if we add 32j on both sides, this gives us plus 28j. And that is our constant, which we can now replace into our equation for displacement as s equal to t cubed I minus 4t to the power 3 over 2j minus 63i plus 28j. In part C, we are looking for the position vector of p when t is equal to 1 second. So when t is equal to 1, we can substitute our t as 1 into the equation we've got for s. So s will be equal to 1 cubed I minus 4 times 1 to the power 3 over 2j minus 63i plus 28j. You can just write this as 1i minus 4j minus 63i plus 28j. And we can now group the i's together. So 1 minus 63 will be minus 62i, and minus 4 plus 28 will be plus 24j. So our Position vector when t is equal to 1 is minus 62i plus 24j meters.